What is centrifugal force? What is centripetal force? Okay, I was reading about the India Meteorological Department that has pushed one satellite in its geostationary orbit of the Earth. Earth, Earth rotates like this. Okay, so Earth rotates like this. Okay, so one is Earth and one is Earth and one is okay. I should break it or I have another one. Okay, so I have Earth. Okay, I have Earth and I have a satellite. So satellite is rotating around the Earth. Okay, there is something called geostationary satellite. I was calculating geostationary satellite. What is the principle under which geostationary satellite works? What is geostationary satellite? Geostationary satellite means if I see a satellite in the sky, no one can see satellite in the sky. I believe International Space Station, someone can see. I don't know at what distance. Generally, the satellites are at distance from 100 kilometer to 400 kilometer. That is the range in which the satellites are located. They are fit there and they revolve around the Earth. Okay, but there is something called geo. So if someone is watching the International Space Station, then he would see International Space Station is making a difference. If sometimes it is above the head, after some time it will be toward the east. Okay, then again, so it is moving, so it has more velocity than Earth. It is 90 minutes, 1 hour 30 minutes. It makes one round of the earth. I believe someone can watch it moving. I have never seen it, but someone can watch it moving or through a telescope or something. Someone can watch the International Space Station in night or something like that. That is moving. In 90 minutes, it makes one circle, one kind of rotation around the earth. Okay, but I cannot use it because my antenna I have considered that is radiating. It is sending some signal and my antenna is receiving. The problem is my antenna must be along the satellite. For that antenna need to keep moving so that it will be toward the satellite. That is the problem. Now there is another satellite comes into the picture and its name is geostationary satellite. Geostationary satellite means you always see the satellite exactly fixed in the sky, exactly fit in the sky. Always. Okay. If that is the scenario, morning you get up, you see it is there one. Evening you get up, evening you see it is there one. There is nothing in the space that is fixed. Nothing. If you see moon, it is rotating with reference to you. A person is standing on the earth with reference to a person. Moon is moving. With reference to a person, sun is moving. With reference to a person, stars are moving. If you see a star right now and then you see a star, if you start tomorrow, next day, it will be a little bit moved. Not only that, year by year also, January 1st, if you see a star or constellation, next year, January, it will be moved. So nothing is stationary as far as Earth is concerned. Nothing. But still, there is a concept of geostationary satellite that is really stationary. Okay. Now we are in calculation that geostationary satellite, how they are placed, at what distance I place a geostationary satellite that it will look stationary. What is the velocity of geostationary satellite? If this is Earth, if this is the Earth, then Earth is rotating like this. Earth is rotating like this. Okay, if Earth is rotating in 24 hours, one rotation of the Earth takes 24 hours. In that sense, if geostationary satellite is kept here, it will also rotate along the Earth in 24 hours. In 24 hours, geostationary satellite will make one round. Like International Space Station, it makes one round in 90 minutes. Geostationary satellite makes one round in 24 hours so that it looks stationary always. And importance is whatever the data we are receiving or sending to geostationary satellite through our antenna, then antenna did not move. It is exactly fixed. It is used in a meteorological department where or television and this area where antenna is directly receiving from the satellite. In that sense, satellite must not change its position with respect to Earth. That is geostationary satellite. Now we are in phase of how to calculate distance of geostationary satellite. If I am revolving a geostationary satellite around the Earth, then at what distance from Earth I should keep the geostationary satellite so that geostationary satellite will move in 24 hour one round. What is the hindrance? Why there is a problem? Why I cannot keep geostationary satellite mere 1 kilometer high? What is the problem? We can make, right? 1 kilometer high. If I make a satellite, it will move the way Earth is moving. 1 kilometer height only. I can maintain it so nicely. What is the hindrance? Hindrance is the velocity. Hindrance is velocity and distance. They are they have something to do with the Earth gravitational pull. Earth gravitational pull. Now consider that there is a magnet. There is a magnet and there is an iron. If I leave the iron, then it will go and stick to the magnet. Okay. Now we say that magnet did a work. If magnet is attracting something toward itself, magnet is losing magnetic field. And magnet lose energy. Magnet did a work. Work done by the magnet when it is making one iron move from one location to another location. Someone can say it is attractive. In other terms, it is working. So magnet is working because iron from this location to this location it moved because of the magnet. Okay. Now when magnet will not work, magnet will not work when the movement of the iron is perpendicular to the direction of magnetic field. If there is a magnetic field, if there is a magnetic field, oh, 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 okay, we are in phase of calculating the distance of a geostationary satellite from the Earth. Now consider that this is the magnet is kept at the center and iron is rotating around a circle in a circular fashion where center magnet is kept. Now magnetic field is radial. Magnetic field every moment magnetic field is 90-degree to this path. If this is the path, then if I take any moment at this path, then the direction of this path is the tangent at that point. Tangent, this is the path direction. What is the direction of this path? Direction is circular. That is all right. But any moment, if I take any point, then direction is tangent at that point. Tangent at this point. This is the direction. This is the here. This is the direction. Here, this is the direction. If someone asks, can you tell me the direction in a vector form or line form, then you at that point you have to draw a tangent line. If this is the tangent line and this is the magnetic field, then it is 90-degree to the direction. So if someone is rotating in a circular direction, then work done is force vector dot product of the direction. If force vector and direction vector are 90-degree to each other, then magnet is not losing any energy. Magnet is not losing energy. This fashion, if magnet is replaced by the earth and this circle is replaced by the satellite direction, if satellite moves in a circular fashion around the earth, then there is no energy lost by the earth. If earth is not losing energy because force field and direction field are that vector are perpendicular to each other. In that sense, there is no energy imparted on the item that is rotating around the earth because of the earth. Okay, in that fashion, it needs the minimum energy to rotate around the sun, around the earth. Otherwise, if earth is attracting it, then it needs to push more energy, because one energy is required to move in a round fashion and another energy is required to sustain because of the earth, whatever. So every satellite, it moves in a circular direction because at every moment it is perpendicular to the earth gravitational pull. That is one thing. Second thing is that if anything rotates, how kind of earth, okay, if anything rotates with the lesser speed, consider an item is rotating around the earth with a lesser speed, not at very high speed, then as per the fundamental, earth is not working on it, earth is not doing any work on it, but still there is a chance that item will be pulled toward the earth. Try rotating around, make a circle. Okay, there is no earth, there is no magnet. Okay, there is another physics fundamental. Make a circle on the ground, make a circle on the ground and start rotating around it. You feel you are pushed away from the center. This force is called centrifugal force. This force, there are two force. When some consider, as per the energy calculation, I said that satellite should move in a circular fashion around the earth so that it will not have any impact as far as earth gravitational pull is concerned. But there is another energy anyone would feel. Another energy, if any person, he rotates in a circle, he would feel that he is pushed away from the center. This energy is called centrifugal force. This energy is called centrifugal force. There is another energy called centripetal force. So if an item is moving in a circular fashion, there is no magnet here. There is no magnet here. If an item is moving in a circular fashion, then item would feel there is a force that is outward the circuit he is pulling. If someone is driving a car or motorbike and then he is making a turn, circular turn with high speed, then he may topple against the center of the earth, center of the circle. If a motorbike is rotating like this at high speed, there is a high chance that he will get toppled against the center of the circle. If circle is there, he starts toppling in this direction because of his speed, he is sensing one energy that is away from the center. This is something called something that is pseudo energy, abstract energy. That energy is not there. Actually, the bike is rotating around a circle and he is making his energy along the circular direction. If I am moving in a straight line, I am imparting energy from my body on a straight line. If I am moving in a circular fashion, I am imparting body energy in a circular fashion only. But there is some energy that is seen that is outward the center of the circle. That energy is called centrifugal force. That is one thing. Second thing is, when I am rotating, I am imparting energy. Where that energy is going, that energy is called centripetal force. The energy calculate the energy what I am losing when I am running in a circle, then I am losing energy in a circular fashion. That energy is toward the center. That energy, because I am seeing the center and I am running. When I am running in a circular fashion, I am seeing the center and I am running. No one see outside and he see the center and he is running. Means your energy direction is toward the center. That is called centripetal force or centripetal energy. Means that is the real energy body is imparting when it is rotating in a circular fashion. But there is one pseudo force that you feel because of your rotation in a circle, you feel there is one more force that is coming into the picture that is throwing you outward. That's why if a road is like this, if a road is like this, and if it is straight, then road is flat. If road is rotating like this, the road is not flat. Road is tilted. If you see more rotation a road is making, more it is tilted like this. Even railway tracks are tilted like this. Okay, in that fashion, if item is moving in a circular fashion, then there is an outward force that is going outside. That force would not topple it. The slant height would adjust it, compensate it. See, so if motorbike is moving in this direction, then the road will not be flat. It will be slightly tilted. So that energy through which it is moving the outside, that energy will hit the road slant height. Okay, in that fashion, the motorbike will not topple. Otherwise, it will topple outward the center. That energy is called centrifugal force, and the energy that bike is imparting, making a round of the circuit, that energy is called centripetal force, and that energy direction is towards center. How much energy he is feeling outward, the more energy he is imparting on the bike, equal energy he will see outside. So energy through which he is rotating, same energy he would feel, that with same energy he is going outside. This is called centripetal force. This is called centrifugal force. Force into displacement is energy. Force into displacement is energy. Someone can consider another example. Now, let's tie this is an iron ball. Let's tie this iron ball with a rope, with a string, and catch it. This is tied with a string. There is a string here that is tied with the iron ball, and here. Now rotate it. You see in Olympic or something, there is a game like that. You rotate it. When you rotate it and then you throw it, when you rotate it, you are rotating it from your body. You are losing energy from your body. The energy what you are seeing that is imparted on this item, that is called centripetal force, and that is towards you because you are losing the energy. But there is another energy this ball is feeling, is that is outward the circle. If you just try rotating it and you are losing energy, that is centripetal energy. But if you just leave it, it will go outside, away from the center. That energy that it is receiving away from the center is centrifugal force. Centripetal force, centrifugal force. Anything rotating in a circular fashion, the actual energy that is released because, or that is the energy that is imparted on the body when body is moving, the energy source is imparting on the body that is moving, that is toward the center. That is real energy called centripetal energy. There is one pseudo energy that guy is moving, that is outward against the center of the circle, that is outward of the center, that is called centrifugal force. Okay, if a satellite is rotating around the earth, there is something called centripetal force, that is earth gravitational pull. There is another energy it is feeling, that it is going away from the center, that is called centrifugal force. If centripetal force, that is the energy, why I am saying energy because of the earth, because the high chance that earth will attract it. If earth is attracting it, then there is energy that is imparted by the earth on the planet. That energy, and when it is rotating, the planet is rotating of its own energy. The planet is rotating because of its own energy, whatever it is. If it is rotating, then there is a pseudo energy it is feeling in outward the earth. One is earth gravitational pull is there, one energy, and another is outward since it is rotating. If it is rotating with less speed, then the centrifugal force that is outward the center, it has some amount. When it is rotating, there is a centripetal force, it has some amount. If these two amounts are not same, then it will be attracted toward the earth. Okay, the earth is attracting any item with some force, and that item is still, it is not moving, then it will get attracted from the earth toward the earth. I mean, If I say, if this is the earth and this is the item, if this item want to stay here, if this item want to stay here, if it is not doing anything, it will get attracted toward earth immediately. If it want to stay at this point, then it has to impart one energy that is away from the earth. If this force and this force, they are equal to each other, then it will stay like that only. This is how helicopter are staying at one location. The energy what earth is imparting on that helicopter, equal equal energy helicopter is generating from the fuel in opposite direction. Because of the fan is rotating, it is generating energy has a direction. It is generating energy in exactly opposite direction of the earth. And if both are equal, helicopter is just staying there. If that is more, then helicopter is moving up. If that is less, then helicopter is moving down. Okay, or he can move on its own, whatever it is. So this is the fundamental of centripetal force and centrifugal force. I believe it will take another time, more time. So we will continue discussion on how geostationary satellite, how at what distance they should be, because we know speed of the geostationary satellite that is fixed. Okay, what is the centrifugal force? What is the distance? So the idea of this discussion, at what distance a geostationary satellite should be kept from the earth, because I know velocity is same as the earth velocity. Velocity, the angular velocity of the geosatellite is same as the earth velocity, angular velocity. At what distance it should be put, so that gravitational pull and the centripetal force and centrifugal force, if they are same, gravitational pull and centrifugal force, if they are same, the geostationary satellite would not fall on the earth. Then what is the dead distance? Okay, we have calculated it. I was reading through internet, and here there they have very different kind of technology. What technology we have generated, that we will discuss.